x86 versus ARM, a simple explanation for beginners. Welcome to The Explainer. Today, we're diving into this fascinating, kind of invisible battle that's happening right now inside the brains of basically all your favorite gadgets. We're talking about a massive architectural showdown that dictates literally everything, from how fast your computer runs to whether your phone battery lasts the whole day. So let's jump right in. Okay, think about this for a second. Why on earth does your smartphone, which, let's be honest, is essentially a pocket-sized supercomputer, why does it last an entire day on a single charge without ever needing a cooling fan? But then your traditional laptop gets burning hot on your lap, sounds like a jet engine taking off, and totally dies in just a few short hours if you forget to plug it in. Well, the secret behind this massive difference doesn't just come down to the size of the battery. It actually comes down to a fundamental difference in how their brains are built. To figure out why this happens, we need to quickly talk about what CPU architecture actually means. And don't worry, we are keeping this completely jargon-free. Just think of CPU architecture as the fundamental rulebook, or like the native language that a computer's brain uses to think and operate. You know, just like we need a language to communicate and follow instructions, a processor needs an instruction set to know exactly how to open a web browser, play a YouTube video, or save a file. And right now there are two totally different languages absolutely dominating the tech world. All right, let's meet our first contender. This is the heavyweight champion, known as x86. This architecture actually goes all the way back to the late 1970s. It was pioneered by tech giants like Intel and then later adopted by AMD. It powered the original IBM PCs back in the 1980s, and by the 2000s, it basically had a near-total monopoly on the personal computing market. It is, without a doubt, the absolute standard for traditional computing power.
So how does it work? Well, the x86 architecture is built on a design philosophy called CISC, which stands for Complex Instruction Set Computing. Let's translate that into plain English. CISC is basically a system designed to do multiple, heavy, complex tasks in a single go. Imagine a master chef who can chop, season, and cook a gourmet meal all in one fluid, really complex motion. It's incredibly powerful, and it actually requires less code to get a job done. But doing all those heavy tasks at once requires a massive amount of energy, and man, it generates a whole lot of heat.
Because of all that raw power and decades of legacy software built specifically for it, x86 totally dominates anywhere that heavy lifting is required and plugging into a wall outlet is easy. We're talking about your traditional Windows desktop PCs, heavy gaming rigs, high-performance workstations for things like 3D rendering, and massive enterprise servers. It's purpose-built to perform complex workloads at incredibly high speeds. But again, it is very thirsty for power. But then, in the other corner, we have our second contender, the lightweight architecture known as ARM. Now, ARM actually started way back in 1985 with a company called Acorn Computer over in the UK, and it was even used in the early Apple Newton in 1993. But ARM truly skyrocketed to massive global popularity when the smartphone era exploded in the 2000s. Suddenly, the world needed a computer chip that wouldn't drain a tiny battery in 5 minutes and literally wouldn't melt inside your pocket.
The reason ARM is just so perfect for mobile devices is because it uses a completely different philosophy. It's called RISC, or Reduced Instruction Set Computing. So instead of doing heavy, complex tasks in a single go like x86, RISC breaks tasks down into bite-sized, simple instructions that it can execute extremely fast. If we go back to our kitchen analogy for a second, instead of one complex motion, it's a chef doing a series of incredibly fast, highly efficient, simple chops. This actually requires far fewer physical transistors on the chip itself, which dramatically reduces both heat and power consumption.
Thanks to that brilliant efficiency, ARM absolutely rules the mobile space. I mean, every single modern smartphone out there, whether it's an Android or an iPhone, runs on ARM. Your smartwatch, your tablet, your smart home sensors, all ARM. But here is the massive plot twist we've seen in recent years. ARM has made a staggering leap into heavy-duty computing. Apple's wildly popular M-series chips, the M1 through M4 that power MacBooks and desktop Macs, those are entirely based on ARM. They've proven that ARM can actually deliver desktop-class performance while still maintaining that legendary all-day battery life.
So if we want to really visualize this battle to make it super simple, think about vehicles. x86 is like a really powerful heavy-duty pickup truck. It uses a lot of fuel, sure, but it can pull massively heavy loads and handle incredibly complex, demanding jobs without breaking a sweat. ARM, on the other hand, is like a highly efficient, lightning-fast electric scooter. It uses practically no fuel, it zips around town all day long, and frankly, it's perfect for about 90% of your everyday tasks. When you actually put them head-to-head across the critical categories, the trade-offs become super clear. For performance on complex, raw computational workloads, think hardcore gaming, x86 still holds an edge. But for power consumption, ARM wins by an absolute landslide. And because it uses less power, ARM's heat efficiency is just incredible. That is exactly why your iPad doesn't need a cooling fan. And finally, battery impact. Because x86 needs so much energy to run those complex instructions, it drains batteries way faster than hyper-efficient ARM.
But let's talk about what this actually means for you in the real world. To put it into perspective, according to the source data, if you take a standard x86 laptop and use it just for normal web browsing, you're looking at around 10 to 13 hours of battery life at best. But if you take a modern ARM laptop, like one with a Snapdragon X Elite or an Apple M series chip, you can hit 20 to 22 hours of web browsing. That is insane. ARM can literally double your device's lifespan on a single charge. It's a total night and day difference if you're someone who works on the go.
Chances are you're practically surrounded by this tech battle right now. If you look around your house, you are living right in the middle of this architectural ecosystem. That traditional Windows gaming PC or Intel laptop sitting on your desk, yep, that's x86 doing the heavy lifting. The iPhone or Samsung Galaxy in your pocket, that is ARM, keeping you connected all day. And if you recently picked up an Apple MacBook with an M chip, well, you're experiencing ARM's very aggressive push into the laptop market firsthand.
So what's the final verdict here? Well, the truth is, neither architecture is universally better. Which one wins depends entirely on what you actually need to do. If you're an enterprise running secure databases, a hardcore PC gamer who needs maximum frame rates, or an animator using legacy software, x86 is definitely still your best friend. But if you value ultra portability, completely silent operation, and a battery that literally lasts from dawn until dusk, ARM is the clear champion. It's really just about picking the right tool for the job.
Which kind of leaves us with a huge, provocative question for the future. As we roll toward the end of the 2020s, the lines are really starting to blur. ARM is getting massively powerful, pushing straight into data centers and premium laptops. But meanwhile, x86 makers like Intel and AMD aren't just sitting still. They're developing these clever hybrid cores to try and match ARM's efficiency. So, will ARM eventually take over the computing world entirely? Or is x86 going to find a way to evolve and become the ultimate efficient powerhouse? It is such a fascinating space to watch, and I really hope this explainer gave you a solid foundation to follow the processor wars. Thanks so much for joining me, keep learning, and I'll catch you on the next one.